Hi, in this video we are going to see about a Python IEEE project which is entitled as Traffic Prediction Using Machine Learning, which is an enhancement of IEEE base paper titled Traffic Explainer, a framework toward GNN based interpretable traffic prediction, which is an IEEE Transaction 2025 journal paper. So before seeing the execution of the project, let me brief about this project. So we all know all over the world, due to the development of urbanization, there is a huge increase in the transportation system. So due to this increase in the transportation system, all major cities in all over the world or India faces the problem of the traffic congestion. So here in the base paper, the authors have utilized the GNN, that is graph neural network, for identifying the traffic prediction. So here in the base paper, they have used GNN based traffic prediction model. But we are not going to do the same as mentioned in the base paper. So now let us see about what is our proposed system and how we are going to enhance from the existing base paper model. So in the proposed system, we are going to use two different models. The first model is gradient boosting regressor and second one is random forest regressor. The first model, using the gradient boosting regressor, we have achieved the train mean absolute error of 0.326 and test mean absolute error of 0.413. Coming to the second model, random forest regressor, we have achieved the mean absolute error, train mean absolute error of 0.131 and test mean absolute error of 0.3379. This is about the performance analysis of our proposed system. Now let us see about the detail about our proposed system. So here you can see the proposed title and you can see the IEEE base paper title, and this is the IEEE base paper abstract. Coming to our proposed project abstract. So as mentioned, due to the increase in the transportation system, there is a major issue of the traffic congestion. To avoid this, we have proposed the traffic prediction using machine learning, which aims to forecast the traffic volume based on the different features. So here this project is developed using Python as the coding language, and we have used HTML, CSS and JavaScript for the front end, and we have used Flask as the web framework. So here, first coming to the data set part, so here we have utilized the data set which contains 48,204 data set records containing the features such as traffic volume, holiday, temperature, rain, snow, clouds, weather description, date and time kinds of things. So now coming to the model, let us show the data set part. So this is the data set that we have used, which contain the metro interstate traffic volume dataset containing the features such as traffic volume, holiday, temperature, rain, snow, clouds, all weather description, date and time kinds of thing. And you can just scroll down and you can see it contains around 48,204 dataset records of it. Now coming back to the abstract part, so here you can see the description of the dataset part. Coming to our proposed system model, so here we have used two regression based machine learning algorithm. First one is gradient boost regressor and random forest regressor to predict the hourly traffic volume. So here the gradient boosting regressor is an advanced ensemble technique that builds model sequentially with each new model correcting errors from the previous one. Coming to the next model, it is random forest regressor. It is a parallel ensemble method that creates multiple decision tree to improve prediction accuracy and reduce the overfitting. So here, as mentioned, we have achieved the gradient boosting regressor with training mean absolute error MAE as 0.326 and testing MAE of 0.413. And coming to the random forest regressor, we have achieved training MAE as 0.131 and testing MAE as 0.3379. So overall, the proposed system is a web-based interface that allows user to input the environmental and temporal features to predict the expected traffic volume dynamically. So all these details have been mentioned in the our proposed system project abstract part. Coming to the existing system, so we are going to consider the base paper as the existing one. So in the base paper, they have implemented the traffic explainer, a framework towards GNN based interpretable traffic prediction. So here the base paper introduced an advanced and interpretable framework for traffic prediction using the graph neural network GNN. So the existing framework is designed flexible permutation based interpretability system that can apply to various GNN architecture without modifying the original model structure. So the existing system, which is a GNN model, processes the traffic data represented as a graph based one, where each node corresponds to the road intersection and edges based representation of the road segments are used. So here, to evaluate the framework, so the traffic explainer system has been tested on 3 real world traffic flow data sets, which contains a sensor based traffic speed and flow data from California and Shanghai kinds of thing. Additionally, they have applied on multiple GNN architectures also. So all these details have been explained detailedly in the existing part of this existing system. Next, coming to the disadvantages of existing system, the main disadvantages of existing system are high computational complexity, dependence on large and structured data set, limited real-time adaptability, complex model interpretability mechanism, limited generalization across different environments, absence of web-based user interaction, resource-intensive model maintenance. These are all the main disadvantages of the existing system, which explain detailedly about the each subheading within. Next, coming to the proposed system, to overcome the issues that is available in the existing system, we have proposed the traffic prediction using machine learning. So here, the main thing that we are overcoming from the existing system is the complex model. So in the existing system, it is a complex model that has been implemented. We are going to simplify it and we are going to predict the hourly traffic volume using the 2 different machine learning regression algorithms. So we have implemented using Python, HTML, CSS, JavaScript and Flask for the web framework. So in the proposed system, we have implemented 2 different machine learning models, gradient boosting regressor and random forest, and we explained about the performance analysis parameters of it in this part. And the proposed system is structured into the key phases such as data pre-processing, feature extraction, model training, evaluation and the deployment kinds of thing. So all these details have been explained detailedly in the proposed system part. Next, coming to the advantages of our proposed system. So the main advantages of our proposed system are simplified and efficient architecture, high prediction accuracy, both the gradient boosting regressor and random forest regressor achieved the high prediction accuracy and real-time prediction capability, user-friendly web interface, enhanced data utilization, robust and scalable machine learning models, reduced operational cost and maintenance, practical application for smart traffic management, interpretability and transparency. These are all the main advantages of our proposed system, which explain detailedly with the subheadings of it. Next, coming to the system architecture, this is the overall system architecture of our proposed system, which contains the input as metro interstate traffic volume data set, and the data set has been pre-processed and feature selection is made and applied with the gradient boosting regressor and the random forest regressor model separately, and we are going to be predicting the results whether it is a low traffic, medium traffic or high traffic based on the traffic volume that is predicted, and then we'll show the performance analysis and the graph part of it. Next, coming to the system requirement, these are all the minimum hardware requirements, and in the software requirements, the project can be executed in Windows 10 or 11. Coding language uses Python 3.12.0. Web framework is Flask, and Frontend contains HTML, CSS, and JavaScript. And this is the IEEE base paper reference. So now let us see the execution of the project. So just go into the project source code folder. Inside the source code folder, we have the traffic prediction and we have the app.py for other files. So here in the address bar, let me type cmd and click enter. So the command prompt window open with the exact location of it. Now type Python space app.py and click enter and kindly wait for a few minutes. So now you can see this URL. Just copy this URL, go to any of your browser. I'm going to Google Chrome, paste it, click enter. So now you can see the project home screen or welcome screen with the project title, traffic prediction using machine learning or smart traffic prediction using machine learning. So just click the login button. So now it will be navigated to the login page. Kindly note that this is a static login page because we have not used any database in the project. So just enter the default username and password as admin and click the login button. So now you can see the login success message and click OK. So now it will be navigated to the upload part where you can upload that data set that is in the CSV format that is provided in the source code folder. So just select the choose file option. So in the source code folder we have given the upload.csv file. Just select this and now select upload data set and kindly wait for a few minutes. So now it takes some time to load the data set into the preview part as we have some more data set records. So wait till it is completed. Now it is loaded completely. Now you can just preview the data set that is uploaded. You can just scroll down and you can see, and just scroll down to the page and you can see the click to train or test button. Just click it. Now you can see the training in progress message. After some time you can see the training finished successfully message and click OK. So now it will be navigated to the important part of the project, that is the prediction part. So here in the prediction part, so we need to enter the features, that is temperature, which is in the Kelvin parameter, and rain, that is how much percentage of rain that has happened in the past 1 hour, snow, clouds, weather main, whether it is clouds, clear, rain, drizzle, mist, haze, fog, thunderstorm, snow, squall, smoke, and what is the weather description, what is the day of the week and date, time. And here you can choose the model, whether it is a gradient boosting regressor model or the random forest regressor model. According to the model selected, the model will be evaluated and it will be showing the prediction result. I'll show you with the both the case. And before going into that, you can see the data set description below this page showing the temperature, which is the numeric format, showing the average temperature recorded in the Kelvin parameter. And you can see that is rain, the amount of rain in millimeter that occurred in the last 1 hour, snowfall, amount of snow that occurred in the last 1 hour, clouds all, percentage of total clouds, average in the sky, weather main, show the textual description of the current weather, whether it is clear, rain, snow kind of thing, and weather description, detailed textual description of the current weather, whether it's scattered clouds, heavy rain kind of thing, date of time, so local time of the data collection hourly basis, and here and month, day, and traffic volume is the hourly traffic volume that is reported on the target variable. So these all the data set description that is given to you for the clear understanding. So now let us show you with the few cases of it. So now I have given the temperature as 288.28, which is in the Kelvin. It is not in Celsius or Fahrenheit. Kindly note that. So I'm just giving the data from the test data. So you can check with the test data or train data, whichever that is provided. So and I have given the rain as 0, snow as 0, clouds as 40%, weather main as clouds, weather description as scattered clouds, day of the week as Tuesday. And so I'm just giving the data from the data set part, and then I'll show you with the future date or current data also. So now I have given the date from the data set part and the time of it, and now I will choose the model as gradient boosting regressor, and let me click the predict button. So now you can see the prediction result, which shows the values that I have entered, and then it shows the model that I have selected, and you can see the traffic volume that is predicted, and you can see the predicted traffic volume result as high traffic. And here we have provided the option to download, that is in a PDF format also, that can be exported in a PDF format for the future reference. So you can just save it. Let me save this result in the desktop. So the data is being exported in a PDF format for the future reference, and you can see the values that we have entered and the prediction result of it also. So now if you wanted to check with the other case, you can just go select the prediction menu, or you can select predict again. So it will be navigated to the prediction part. So now let me enter the temperature for Kelvin in the 10-minute format as 285.45, rain as 0, snow as 0, clouds 1%, weather as clear, weather description sky is clear, day of the week Wednesday, date 2/10/2012, time 11 p.m. and let me select the model as random forest regressor and let me click the predict button. So now you can see the predicted traffic volume and you can see the predicted result is low traffic. And similarly you can just export the result in a PDF format for your future reference or optional case. So now you can see the exported result. Now I'll just predict for another case. Now for this case I'll just give 293.85 Kelvin, rain as 0, snow 0, clouds 40%, weather as clouds and scattered clouds, day of the week Thursday, date, time, and select the model as gradient boosting regressor and go for the prediction part. And now you can see the traffic volume that is predicted, which is a predicted result as medium traffic. So now I have shown you 3 cases from the dataset part, from the high volume day traffic, low volume traffic, and medium volume traffic. So now let us show with the future date of it. Now I'll give the temperature as 271.23 Kelvin, rain 0, snow 0, clouds 20%, weather as clouds, weather description as few clouds, day of the week as Monday, date as future date, today is 28/10/2025. I'll just give 3/11/2025 time and model. Let me select the predict button to predict the traffic of this data and you can see the predicted result is high traffic. So in this way you can check with the various values with the data set part that we have trained and test data or train data, or you can give the future data and according to the values that we have trained up, and it will be showing the predicted result of the traffic volume and the predicted traffic level, whether it is a low level traffic, high traffic, or medium traffic kinds of thing. So now let us move to the next part, that is the performance analysis parameter. So just select the performance analysis menu. It will be navigated to the performance analysis part where you can see the performance analysis of both the model of the random forest and the gradient boosting. The first one is with the training and testing accuracy of it, and next one is the absolute mean error comparison, showing the mean error of the training MAE and the testing MAE of both the model of random forest and the gradient boosting. And next one is R2 score comparison, and next one shows the model execution time for both the models, and next one shows the confusion matrix representation of it, and next shows the overall system efficiency with the model accuracy, system responsiveness, data processing efficiency, and prediction stability kinds of data. So in this page you can see the performance analysis of the system with both the model of it. Now let us move to the next part, that is the chart part. So in the chart part we can see the various static charts showing the average traffic volume by hour. These all the chart that is represented here or represented based on the data set that we are trained up. So first chart shows the average traffic volume per hour data. Next shows the average traffic volume by date of the week. Next shows the weather impact on the traffic volume. So clear weather, clouds, rain, snow, mist, drizzle kinds of features. Next shows the temperature, which is the traffic volume chart. And next shows the top features importance, hour, day, month, temperature, clouds, rain, holiday, weather kinds of data. And here shows the model performance comparison showing the training accuracy and the test accuracy of it. And next shows the traffic volume heat map. So these are all the charts that is available in the chart part of it. So now let me log out. Before completion, let us see the frequently asked question for this project. So the first question is, what is the main objective of this project? So the primary objective of this project is to predict the hourly traffic volume based on the various environmental and temporal factors that is available in the dataset part, whether weather condition, temperature, time kinds of thing. So we are using the machine learning algorithm for the traffic management and congestion control and decision factor for smart city application is the main objective of this project. Next question, which technologies are used in this project? So we have used Python for the front end, we have used HTML, CSS, JavaScript. For the backend we have used Flask, and for machine learning libraries we have used scikit-learn, pandas, numpy, matplotlib. These are the technologies that work together to build, train and deploy the predictive model accessible to the web interface. Next question, what algorithms or models that been implemented in this project? So we have used two different machine learning models. One is gradient boosting regressor and another one is random forest regressor. Next question, what data set is used in this project? So we have used metro interstate traffic volume data set, which contains 48,204 data set records, which shows the attributes like holiday, temperature, rain, snow, clouds, weather, description, date and time kinds of thing. Next question, what are the key features of the data set? So the data set contains a holiday, temperature, rain, snow, clouds, all weather, main weather description, date and traffic volume kinds of data. Next question, what performance results were achieved by this model? So in the gradient boosting regressor, the train mean absolute error is 0.326 and test MAE is 0.413. For random forest regressor, its train MAE is 0.131 and test MAE is 0.3379. Next question, what is the mean absolute error and why it is used here? So mean absolute error MAE measures the average difference between the predicted and the actual values. It is used to evaluate the regression model performance. So here this is a regression model project, so we have used this performance analysis, and here the lower MAE value indicates more accurate prediction. In this project, MAE effectively quantifies how close the predicted traffic volume is to the actual recorded traffic. Next question, how does the system work? So first the user enters the parameters like temperature, rainfall, weather type and all those things, and they will be selecting the model, which model they wanted, and this input is sent to the Flask backend where it is pre-processed and passed to the selected model. The trained machine learning model predicts the traffic volume and results, and it will show the result whether it is what kind of traffic volume, low, high or medium kinds of thing. Next question, why were gradient boosting and random forest models have been chosen for this project? So we have used gradient boosting regressor because it is well known for the fine tuning prediction errors, and random forest regressor provides the high accuracy and reduces the overfitting problem. Next question, how is this project different from the existing system? So here in the existing system, the base paper, they have used a GNN based framework, that is a traffic explainer, but the model that is applied are complex and computationally expensive. So to overcome that issue, we have provided lightweight, interpretable and web deployable solution. Next question, who can use this system? So the traffic authorities, urban planners, commutators and research and students can use this system. Final question, what are the practical applications of this system? So the practical applications are real-time traffic volume forecasting, congestion maintenance and route optimization, scheduling for public transport and logistic, data analysis for smart city infrastructure planning kinds of applications are available for this system. These are all the frequently asked questions for this project, and this is all about the project traffic prediction using machine learning. And thank you for watching.